All right, Brian, we're live with another Wi-Fi podcast. And first, we got to talk about paint protection film, PPF, for the Tesla, because I've been getting some quotes. As you know, 4 days after I got it, I was on the highway and something flew up and scratched the front. Right?
It didn't chip, though.
It did chip. Yeah, I mean, it scratched the front. It chipped it.
Oh, you showed me that. I'm sorry.
Yeah, man. So I had to get the whole nose repainted at great expense. No, it wasn't that bad, but I had to get the nose repainted. Now, I've never done PPF, XPEL film on my cars before because I'm always really careful, but it seems like this one is real. You got to be, extra careful with Tesla. And I don't like any chips in my paint, so I think I'm just gonna do. I'm gonna do the bumper and the hood for $1,500, or for $2,000 I could do the whole front fenders, hood, and nose. What would you do?
I would not burn the money to do that.
You wouldn't even do it. Yeah, but
No.
I know I'm against it. But I know. Here's the thing: if I hit something else hits that front, and I'm gonna put a lot of miles in this car, it's not just sitting in the driveway. I'm gonna take this thing cross country. I'm gonna drive. We're going to Texas in this thing soon.
You are?
Yeah, not soon, but maybe in March or something.
Not right now.
Not right now. I'm not going anywhere until I see those numbers come down. But yeah, so this thing's gonna be taking a lot of trips. So, at least I want to do the nose.
Yeah. Yeah, because we talked about it, when you're on the highway, that's where you get all the chips and things like that.
Yeah. I mean,
that means you need to put film on your windshields as well, too, right?
I'm not gonna do. I have glass coverage. I'm not worried about that. I'll just put a claim in for that. But I don't know. But now I'm thinking maybe I'll do the front fenders too, because they're kind of exposed. It's almost like the hood. But what do you think? You don't need the fenders?
I mean, if you're doing the hood, you might as well do the fenders as well. Right?
Yeah, I guess that's what they want to do. But I was trying to get them down a little bit. But so yeah, I think I might do that. I'll let you know.
Yeah, because you're gonna get the hood done, and then you're gonna get scratches on the fenders, and you're gonna be like, I should have did it. So
it's guys, I should just do the whole car. Spend $5,000, do the whole car, right?
Yeah.
Every single inch, the glass. I saw
resale value up.
Yeah, I mean, whatever, but I saw this guy getting it done in Thailand, and this company that was doing the paint protection, they did everything, every single, the glass, the mirrors, they put tinting in there, because the sun's so strong, they put tint everywhere. Whole thing, it's probably $1,000 to do it there. You know what I mean?
Yeah.
We're here, it'd be $10,000 to do something like that.
$10,000.
So, all right. So, what do we want to talk about? Wi-Fi. So, okay. So, there's been a client bridge shortage for a while now, right? It's hard to get Wi-Fi client bridges for point to points. Now I've got a couple in stock still. I've got one end station AC kit in stock, which is a good 11 AC bridge, and then I've got some of the ENH 500 kits available too, but those are going to go fast. Those will probably be gone in a couple days. Also, I have the Ruckus P300 bridge kits available. They're really good at a higher price point, but those have been available for a little while now. I don't know how long, but I have those available right now. But what else can you use if you have to bridge buildings that are pretty close by, right?
Majority of the point to point that we end up doing is 500 feet, right? Right.
Maybe
a tops 1,000 feet.
Yeah.
But I mean, we can go beyond that, but typically it's 500 feet. It's not very far, or it's even shorter than 500 feet.
So I would say shorter than. So if it's less than 500 feet, you can do point to multi-point, outdoor access points, right?
Yeah, I mean, you can even the access points that we have now, right?
Yeah.
you can remove the antennas. You can put directional antennas on them if you needed to.
You could, but that gets messy. With the four plus antennas on those things. Yeah, and the connectors and everything. It's tough to do. I know we used to sell all that stuff, but it gets messy and it's too complicated. You could do it, yeah, but I think a lot of times when they put external antennas, they get worse results than with the stock ones now.
Well, yeah, because they put like crazy long lengths of cable antenna.
Right.
Antenna cable.
Yeah, I mean they try to mount
so there's loss, right? So like every connector that you put on there, the distance of the antenna cable, there's loss.
Right.
So yeah, I mean and if the distances are different from one another, that's another problem. So yeah, you introduce like some failure points, some problems there. So
yeah,
I mean,
let's just leave those antennas on there. The ones that came from it came with the factory antennas. Use those. Make sure they're screwed onto the right connectors, the 2.4 and the 5, because they are marked. But anyway, so if you use something like the Ingenious, the ECW160 or the ECW260, you can put those in mesh mode, right? And that way you can use that will bridge two buildings, no problem.
Yeah, for sure. You can you're setting up a cloud managed point-to-point or point-to-multi-point when you do that.
Right.
So, yeah, I mean, I know there's guys out there that will go the more cost-effective way.
Yeah.
But I would definitely do 260s. I mean, the bandwidth is there. And the nice thing about those devices, the ECW160, ECW260, you can choose what band to use to mesh on. So you can do it on 2.4, you can do it on 5 gigahertz. It just really depends. It kind of depends on the distance too, and like what kind of speed you're trying to achieve. So most likely you want to do it on 5 gigahertz, right? You want to maximize the speed as much as possible. And I would say I would keep it to like just 2. You could go beyond 2. But if the less you do, the more performance you will have. The more you start to mesh together, the less the speeds will be.
Right.
So you just got to be really careful of that. with there's repeating, and then there's meshing. And meshing, you can get a little more speed out of it than repeating, but I try to stick to like 2 devices only. Right?
Yeah, that's definitely the way I do it. So if you had let's say you had 2 buildings that you wanted to bridge to, I would within the Ingenious Cloud you could set up 2 different SSIDs, right? That you could bridge, and you could hide those too. You can make them hidden so that they're just bridging and no one is being able to connect to those APs.
You don't even have to create an SSID.
Oh, really? Okay, so you could just put them out there, and the mesh is going to connect.
Because you can choose, like, on the radio, you can choose to mesh on the radio.
Oh, yeah.
Or you can choose to mesh and broadcast on the radio.
Got it.
So in those situations, you would just mesh.
Yep.
Because you don't want to broadcast out and say, okay, please connect to me, that kind of thing. And then you just disable the other radio. If you're not using, like, 2.4 and you're meshing on 5, you just disable 2.4.
Yeah, so that makes it easy to do. You just basically add the device to your network, you enable meshing on the 5 gigahertz radio, and then just disable the 2.4 gigahertz. Now, but if you had 2 buildings and you wanted to keep them separate, on 2 separate AP pairs, then you just create 2 networks, right? You would create network 1, network 2, or bridge 1, bridge 2, and add the devices to those networks.
Yeah.
Because what you don't want is to have, with meshing, they try to find the shortest path. So you don't want to have multiple hops in there if possible.
Yeah, so you definitely, I see what you're saying.
Yeah.
You definitely want it on 2 different networks.
Yeah.
Within the Ingenious Cloud, you would set up 2 networks under one organization, and they would be known, the network name would be known as Link 1, Link 2,
right.
That kind of thing.
Yep.
So that actually gives you, in regards to monitoring it remotely, that like really kind of organizes it like really well.
Yeah.
You just the the company name of the organization, and you can see, oh, these links are up or down, that kind of thing. So you could definitely do that.
Yep. So that's definitely a way to do it. You know, point to points. If you're over 500 feet, I'd say you got to start looking at a real point-to-point solution with directional antennas. But within that 500 feet, I mean, you could use the 160 or the 260. And the 260, like you said, will have higher bandwidth, like closer to a gig of actual throughput. Whereas the 160, you'll probably get maybe 400 meg at short distances, something like that.
Yeah. The other good thing is, like, you can really crank up the output power.
Yeah.
Because you're not communicating with client devices. You don't have to worry about roaming or anything like that. So you can crank up the power. You know, I know you don't want me to say this, but you could actually increase the Omni antennas on there.
You could.
It's a direct connect.
Yeah. You could, if you can find them. It's really hard to find, Nathan, because people have been asking me, like, there's not a lot of SMA 5.8 gigahertz antennas that you can really get now.
Okay.
Yeah, there's you know, like we go to Elcom, right? They have the pretty big assortment in the U.S. There's really not much out there, so I mean they can try whatever they want, but I don't know. I think just stick with the stock ones. All right, so there's a couple options if you need to do point-to-point bridging right now. And then you can also use the rest of the meshing, the cloud equipment, indoor APs and switches. So at the remote site, you can put a cloud managed switch, plug it into the bridge or into the AP. AP will get its power from the switch, and then you can plug in, you know, the rest of the network in the other building into the switch.
Oh yeah, yep. It would be seen as like one whole network.
Network on the cloud. So yeah, good way to manage. And I know you do have some cloud managed point to point, you know, product coming soon, right? Or in the pipeline, maybe. I don't know. No. All right. It's possible. But, all right, so what else do we want to talk about? The Airguard.
Right?
Yeah, Airguard, yeah.
Yeah, so we just released 2 access points. I think probably most of anybody watching. Oh, by the way, if you are currently meshing right now, you're doing a point-to-point using meshing, please comment in the
let us know how that's working.
Yeah, let us know how it's working. Let the audience know how it's working. We'd like to hear more about it and kind of like your installations on point to point. They're always interesting to hear about because there's so many different things that you can do. Yeah. But so we just back to Airguard. Airguard is like basically Ingenius's whips and WIDs, right? So it's a security feature that's built within the cloud, and we launched 2 access points that have scanning radios, and those scanning radios are specifically for the security side of things. So within cloud, you can actually define rules. You can define rogue rules, and you can define whitelist rules. And the reason you do that is to basically identify any rogue devices like on your network, right? Is the purpose of it. So once you define the rules, those access points will scan the environment and identify if there's any other devices out there that are broadcasting similar SSIDs to what you're doing within your corporation or in your network. Obviously, the cloud device or the cloud system already knows what's within the network, your network, so it can scan and find rogue APs that are outside of your network that are broadcasting similar SSIDs to you. So you can putting in rules will identify those things, and then you can make calls on, okay, this is a rogue device, this is not a rogue device, it's just a neighboring device, right?
Yeah, so, I mean, every Wi-Fi system has, like, rogue displays in there, right? So people kind of ignore them now because rogue is like anything other than what you set up, right? But this system, let's put an example out there. You have a guest network with an open SSID with no encryption on it for guests to come in, sit in your lobby or whatever, connect to, right? And the system knows, the Ingenious Cloud knows about that one. And if someone comes and sets up the same SSID out in the parking lot, it's gonna flag that as a rogue right away.
That's right. And so you're able to identify, okay, there's something suspicious happening on the network.
Yeah.
And I need to identify where that's coming from. So our system is able to identify like a couple of different things. So it also offers the ability to, you can set the rules, right? And then you can look for, any suspicious, like evil twins, right, for example. But you can also, it will scan the environment and tell you what's out there and being broadcasted.
Yep.
So you can see like, okay, these are my neighbors. Wait, this guy looks a little suspicious, and you can move them to like the rogue SSID category. So you're aware of that issue. And then we're doing some other nice things with like detecting like evil twins, malicious attacks, and like RF jamming. So those are some of the other items that we've added into the system. And the reason I bring that up is because there's not a lot of vendors that are doing that right now.
Yeah.
But so go ahead.
Oh yeah. So the other big thing that people are going to want to use this for is, let's say an employee brings in his own device and plugs it into the drop at his desk, right? That what you even see, I don't know, people have seen this in their own companies, I'm sure. So they plug it in their desk. Now, the system's going to show that as a same network rogue?
Yeah. Well, yeah, it's going to detect that. So in our system, we can detect, you can simply spoof, like an access point, just spoof the SSID.
Yeah.
But there's another method where you spoof the SSID and you can spoof the MAC address of the access point itself. Right. And that's even harder to detect. In our system, we're able to identify just a simple spoofed SSID or the MAC address. So it will look at the MAC address as well. So it will identify that device as like a rogue SSID or rogue device. So it would identify that and display that to you. The nice thing about our system is that we have these scanning radios and these access points that are pretty much spread out within the network. So it will localize like where that is coming from. So it will tell you, the access point in this conference room is identified a rogue device. So it will actually tell you where the device is located as well.
Yeah, that's a good reason to have these things distributed. Because you'll know where that attack's coming from, if it's out in the parking lot or if it's somebody. But if it's on somebody's desk, you're going to be able to track that down pretty easily too. It'll probably trace it back to whatever switch it's plugged into.
And that's pretty common. The issue you brought up.
Yeah.
I don't know if a lot of people know this, but rogue APs are normally detected in the enterprise space, and it's normally from employees.
Employees.
Not trying to do anything malicious. They just, they plug in whatever device into the network and they open up the network, and that's just an access point or that's a way in for somebody trying to do some damage to the company.
For anybody. And and the other thing is with these, the blacklist and the whitelist in there, you're limiting like how many notifications you're going to get, because you don't want this thing just being like, sending
everybody's a rogue.
Everybody's you don't. If it starts sending notifications every minute of new rogue APs, then no one's going to pay any attention. So with this, with the Airguard and the AP, the scanning APs, you put the rules in there, so it's only going to notify you when somebody plugs that thing in on their desk. You'll get a notification. You'll know. You'll go right over there.
Yeah. So and where Ingenious is located, we have a couple of neighbors, and when I look at other SSIDs, there's a lot of other SSIDs. So you just mark them as, they're okay. So you don't get constant, or you don't have to. So you don't get notifications like you were saying.
Right.
So if they're not showing up under rogue SSIDs, then, you won't get a notification. But you do have this ability you have visibility into the Wi-Fi environment, the radio environment, and understand like what's out there. Right.
Yeah.
But yeah, so the system will send like alerts, and that they'll send alerts through like your mobile device, through the cloud interface, and through email as well.
Sounds good. All right, anything else you want to talk about?
Did you want to talk? Well, you got 10 minutes. Do you want to talk about high channel or no?
Yeah, just hit on high channel utilization for a minute. I had a customer ask me about that. So what does that mean when they in the Ingenious Cloud or any system, when they see high channel utilization? What does that normally mean?
High channel utilization is saying basically it's looking at multiple things, but for anybody providing Wi-Fi, it's looking at 2.4 and 5 gigahertz to see if it's basically a clean frequency or if it's a dirty frequency.
Yeah.
Is really what it comes down to. And so, if you're on a particular channel, say 5 gigahertz, you're on a particular channel and you're seeing high channel utilization, what you want to do is maybe change the channel to another channel or change it to a different channel.
Yeah.
But what we've seen is that when you have a lot of clients, you do see high channel utilization in scenarios. So, I've seen spike. If you're seeing spikes of high channel utilization, that's not necessarily means that you need to change the channel. But if it's consistent, if you see consistent high channel like 50% and above, then you want to really start to consider changing the channel.
Or you could add additional access points. It could mean that you just have too many clients on that access point, right? Using that one channel.
100%,
so that's something also, like if you're seeing that and it's your clients in there, let's say that you're 1 second, Alexa, open the garage door. Getting a shipment of ingenious equipment right now.
Yeah.
There it goes. So if let's say that you're off by there's no other networks around you, right? Which never happens, and you're seeing that high channel utilization. That means your clients are causing that high channel utilization.
Yeah. Yep.
So in that case, that means probably you need additional access points there to satisfy the traffic in that one area.
Yeah. In our situation, it was a lot of broadcast traffic is what we were seeing.
Yep.
From the client devices, because there were just so many clients.
So it could be problems with broadcast traffic also that you could filter out, right? So you can put in the multicast to unicast filtering, BCMC suppression. That's something you could try if you're seeing it on like every single AP. What was causing that? Like Sonos maybe, or Apple?
In that scenario?
Yeah.
It was just the amount of broadcasting on the DHCP.
Okay.
When new clients would come on board,
yep,
you would see a ton of traffic during those times, and so you're communicating to wireless devices. Right?
Yeah.
So you would see like channel utilization go like really, really, really high.
Yep.
But there's a lot of devices that were within the network. There's gaming devices, there's Sonos devices, there's all kinds of devices. And in this particular network, so that was another method. So changing the channels and things like that may have not fixed that issue.
So if you have a very large network, like in a school campus or something like that, then it's probably like broadcast from your actual clients. So you may want to look at using more VLANs to separate the broadcast domain. If it's in like a home situation and you're seeing that high channel utilization, it may mean that you need more access points. Or
that's right.
Or you're on a channel that your neighbor's using, so maybe you switch the channel.
Yeah. Exactly.
Yeah. All right, sounds good. So, all right, well, I'll put a link below to all the bridges that are in stock right now, in case anyone needs point-to-point bridges, and also the ECW160 and ECW260 if you want to use the meshing to bridge two buildings that are close together. I think, again,
if you want to make a comment and let us know how that's working, if you're using meshing as a point-to-point kind of solution, we'd like to hear about it as well.
Yeah, because we usually, on normal times, we'll tell people, use the point-to-point. It's better, right? Just use point-to-point because it's a no-brainer because it's in one box. It's pre-configured for both bridges, and we know it works. And it's easier to troubleshoot that way, right? If it goes down, it goes down. You put a new one up. This is going to be a little bit harder maybe to troubleshoot, but it's going to work, and it may be your only option right now.
Yeah, exactly. Yep.
All right, sounds good. Remember to like and subscribe for more help with Wi-Fi.